In this video, we are going to study about our types of spillway. We are starting our next session, topic, that is a type of a spillway. In that, we are looking for our first spillway type, that is a shaft spillway. Shaft spillway is also called as an inlet spillway, morning glory spillway, or it is also called as a bell mouth spillway. See, it is the spillway in which it has the horizontally positioned lip through which water enters and then drops through a vertical or sloping shaft and then to a horizontal conduit which convey the water past the tank. You can see here in this diagram. See, basically this type of a spillway can be located on the upstream section. Here you can see, okay, and this will be the tunnel that will be constructed below the ground surface area. The spillway crest and the spillway inlet looks like this upper section, and the inlet of the spillway is a more wider one, so that the maximum amount of the water can be taken from this portion. It will be passed through this vertical shaft, and this vertical shaft is connected with the concrete line tunnel. You can see this control weir, or this shaft will be, or it is a vertical one. It is let down on the vertical position, hence it is called as a shaft. See, basically this type of a spillway, sometimes it is in a partially submerged, or sometimes it is fully submerged. Once the water will get start increases because of the heavy rainfall, so this water will get come up to this, or will discharge through this inlet, and it will comes over it will travels to the vertical shaft, and then again it will pass through this tunnel section. You can see here also the inlet will be provided, the shaft will be provided on the upstream side, and the outlet will be provided on the downstream side, which is again connected to the river or the natural water resources. So the amount of the water that will be passing through this surplus amount of energy that will be passing through this shaft spillway will come and flow through this tunnel section, and then it will be discharged into the river safely. So there is a no need to no need to provision for the or spillway cannot be provided along with the body of the dam. Basically, the earthen dam or the rockfill dam, where the spillway provision becomes very critical. So in that type of a dam, we can provide such type of a spillway. So a shaft spillway can often be used where there is an inadequate space for other types of a spillway. So no other spillway can be, or the suitable topography is not available for any other type of a spillway. So in that situation, we can adopt this shaft spillway. So it is generally not desirable to use a spillway over or through a earthen dam. Yes, we have discussed it because of the compacted layer, because of the earthen material that will be used in the construction of the earthen dam. So basically, the spillway construction becomes very critical and very um, unsafe. So such type of a hydraulic structure that is on the earthen dam location, if there is a no enough space, or if the topography prevents the use of any other spillway, that is a trough spillway or a side channel spillway, the best alternative should be the shaft spillway. If the topography is not suitable, if the any other type of a location that cannot be adopted, so for this the shaft spillway is the best and better option, or alternative for the discharging the water surplus amount of the water. Generally, the shaft spillway normally consists of these three elements. You can see the three element, that means overflow control weir, means this entry point. This entry point is nothing but your overflow, the surplus amount of the water that will be come here. It looks like a weir, or it looks like a small outlet or a small inlet that will be not a small, but it will be a inlet that will be provided, so that through this section, through this wider section, the extra and the excess amount of the water will get passed through this shaft, and then it will travel to the tunnel section. Then definitely second element will be the vertical control or vertical shaft, and the third one is the closed discharge channel. The closed discharge channel is nothing but this closed tunnel. A tunnel will be closed, and once you extract the water through it, it will be passing over it, and again it will be discharging the water on the downstream section. So in that manner, or by using that element, the shaft spillway may fulfill its purpose. Basically, this small shaft spillway may be constructed entirely of a metal or a concrete pipe or a clay type. See, the vertical shaft of the large structures is usually made up of this vertically let down, or this vertical shaft will be made up of with the RCC, because the tremendous energy and the tremendous kinetic energy will be passing through it. So for protecting such a area from this energy, this whole structure, vertical shaft structure, will be constructed by the reinforced concrete, and the horizontal conduit, that tunnel, this tunnel will be made up of with the, or this will be properly constructed in the rock impermeable strata, so that the kinetic energy, whatever it is, the tremendous one or the maximum or minimum, it does not affect or does not create any effect on the such a element. So the your discharge criteria and discharge procedure is keep going on without any problem, without facing any problem. So this sometimes the divergent tunnel, this is used for diverting the river water during the construction, which may be plugged at the upstream end and then connected to the vertical shaft. Like here you can see here, during the construction of this, or during the any maintenance procedure, or any such a any the process that will be carried out on the upstream side, because there is a highest amount of the water that will be stored here, and we want to do the maintenance, we want to do any other inspection process. So or even during the construction of this shaft spillway also, one divergent tunnel that will be constructed, and through this divergent tunnel, the water that may get increased, that will be coming here, and that will be connected to the vertical shaft of the spillway, and then it will be passing through the outlet section, or it will be directly connected to the natural resources, that is a river. So in that manner, this shaft spillway will carried out, and the will work. So this is the one of the spillway when the topography is not suitable, and when the other type of spillway cannot be adopted. See, the small shaft spillway may constructed entirely, yes, of a metal or concrete pipe. Yes, obviously we have two types of a shaft spillway. One is the standard crest type and the flat crest type. See, in the flat crest type, the weir section proceeds free fall section, while in the standard crest type, there is a no weir section. The water begins its free fall immediately upon leaving the crest. Here you can see the two type, standard crest, and this will be the flat crest. So the difference is given here. Now next type of a spillway is the side channel spillway. You can see the diagram here. You can see here the dam is constructed. This dam is constructed. This is your upstream section. This is your downstream section. The side channel, that means the channel in which the flow after passing over the Ogi crest. See, here you can see this top section. This top section of the dam will be continuing and will be extended up to this. Here you can see the spillway. Ogi crest will be provided on this part. This is constructed on the side of this hydraulic structure. Side of this hydraulic structure. Hence, it is called as a side channel spillway. See, basically what happened once the water will get increased in this upstream section, this increased water level will pass through this spillway crest. And generally, this spillway crest is shape of this crest is given as a ogee one, that is a smoother one. So the water that will be passing over this, it is carried out in this channel, which is running essentially parallel to the crest. You can see here the spillway crest is provided in this manner, in this horizontal level, and be completely and absolutely parallel to this. This side channel will be constructed. This will be the top view and the plan of this side channel. You can see after passing through this side channel, the water will again connected to the natural river flow, so that the water that will be coming from this spillway, or the surplus water that will be increased, this will be carried out through this side channel. Basically, this side channel is provided to dissipate the kinetic energy at this section, at this bottom section, or at this lower section. You can see the systematic diagram of this channel also. After coming here, yes, imagine this side channel is, we are looking in the front section. See, this water will be carried out in this through this channel, through this spillway. Here I will show you. If this is your spillway crest, water passing over this spillway or Ogi crest will be carried out in here. It will run, you can see it will be coming here, and it will be perpendicular. It will be flow in the 90-degree. The angle which the angle mixed with this flow, or with this side channel, will be a 90-degree flow. And this overall side channel section, that will be parallel to this spillway crest. So what happened exactly? See, the discharge characteristics are same as that of a ordinary spillway, ordinary overflow spillway, but it is basically suitable for the earthen and rock-filled dams in a narrow canals, and for other situation where direct overflow is not permissible. See, the shaft spillway, even siphon spillway, no, not a siphon spillway, but even a tunnel spillway, even a this side channel spillway. Basically, this spillway is located to the sides of the your dam structure. It is not constructed along the body of the structure. So yes, we have seen that earthen and rock-filled dam generally require the more inspection, more maintenance. For this criteria only, we are keeping the spillway or we are locating the spillway on the side, the bank sides of the dam structure. So here, this type of a spillway is also suitable for the earthen or a rock-filled dam. It is also adopted where long overflow crest is desired to in order to limit the surcharge head and abutments are steep. It is also desirable where the spillway discharge is to be connected to the narrow discharge channel or tunnel. So the discharge that will be carried out from the spillway, that will be again coming, and that will be passing on the side channel, and completely you can see this when the abutments, the condition is that the abutments of the dam will be in a steeper condition, then you can provide this a side channel. So along with the gravity flow, this flow will be carried out, and definitely the kinetic energy will be dissipated at this section. This section is a wider one. So because of this, your flow will get and your energy will be dissipated, and the safely you can safely discharge the water through this river section. So yes, this is also one of the best and good example of a spillway. Then we have a straight drop spillway. This is the simplest type of a spillway, which is constructed in the form of a low height weir, that is like this low height weir. So having a downstream face either vertical or nearly vertical. That means either it will be looks like a rectangular block, or either sometimes it will be given as a inclined position. Water drop freely from the crest. Here water comes here and it will be directly falls on this bed level. So the underside of the falling nappe is ventilated sufficiently to prevent a pulsating and fluctuating of a jet. See, occasionally the crest is extended in the form of a overhanging lip. Sometimes this will be look, or this will be the shape will be given like this. The overhanging lip is provided to direct the small discharge away from the face of the overflow section. See here in this section what happened, directly the falling of the jet will create a, or will affect this bed level, because in this period or in this section, the negative pressure and the cavitation will be formed continuously. Once the water will get increased, because of this increased water, kinetic energy is also increased, and because the we didn't dissipate, because we are allowing this water to fall directly on this bed level. So because of this portion, this bed level will get bridged out and will get depressed. So to avoid this, generally sometimes the overhanging lip will be provided. I will show you in the next diagram. Here you can see the spillway that will be provided without giving a downstream protection, that will be looks like this. And you are provided the overhanging lip, the portion of the water will fall uh, ahead and beyond this toe section of a spillway, so that the section which is nearer to the toe section of the spillway, that will be protected. Here again, for providing and for giving the more protection for the downstream section, the when the water that will be carried out from the upstream part, that will be carried out here, and the downstream protection work will be provided. Here you can see here this is the impact block basin, and the impact block will be provided, and this whole channel or a whole bed will be constructed with the rigid material with the concrete part. So what happened, because of this, the water that will carrying out the kinetic energy that will dissipate on this, and that will continuously give the pressure on this section, and certainly after forming a hydraulic jump, and this water will get increased, and slowly after getting over here, after reaching up to this block level, again the energy will be dissipated and safely it will discharge on the natural river flow or on the downstream section. See, in the first diagram, in this diagram you can see the straight drops will be constructed on the sound rock. So after someone the following jet and will form a deep plunge pool. Where erosion is not permissible, a low secondary dam may be constructed to create an artificial pool, or a concrete apron may be provided. If the tailwater depth are sufficient, a hydraulic jet jump will form when the free jet falls on the flat apron. See, this type of a spillway is not recommended for the high head, since the vibration caused by a falling jet might crack or displace the structure exactly, with the danger from the failure by piping or undermining. Then you can see the third diagram, that in that we are providing the impart block basing, which is useful for the low heads. See, this block gives us a reasonably good dissipation of energy for a wide range of a tailwater depth. The energy dissipated by means of a turbulence caused by an impingement of the flow upon the impact block. So this is the three types of a spillway. Each spillway has its own characteristic, has its own importance. So basically, by analyzing, by judging all the condition, by doing all the analyzing procedure, just we need to select the proper type of a spillway. Thanks for watching this video.